Hi everyone. We're still in the chapter entitled Surface Area and Volume. So we are talking about computation and calculation of surface areas and volumes of solids in three-dimensional space. So in this part, we will focus on volumes of composite solids. So we don't have a simple, easy generated solid, for example, like cube, like pyramids, like prisms that we know how to compute their volumes, and we have their rules and formula about the computation of their volumes. But right now we are focusing on composite solids. So composite solids, we mean like two solids sticks to each other, like cylinder, prism, cylinder, pyramids, and so on. So normally, how can we calculate the volume of composite solid? It is a good question to answer here. So normally in the first step, we should break the composite solid into simpler solids, and then it is must to find the volume of each one separately, because we know the formula about the volume of simple solids and not about the composite solid directly. So we find the volume of each simpler solid separately, and then we add or we subtract the resulted volumes according to the current situation. We want to illustrate, and it is most important to illustrate what we described before by a simple example. We have this composite solid. It is not a simple solid because we have a cube, and on the top of it we have a small cylinder. So normally we have a cube because we have all the sides, all these sides in this cube. In each faces are rectangles, all are squares with the same lengths. So normally it is a cube, and we have a cylinder with two cylindrical surfaces and lateral face. So we know that the volume of a cylinder is the area of the circle pi r squared by the height of the cylinder. It is easy to memorize this formula. And what about the cube? Also, the area of the square, the base, okay, times the height, which are all equal, because all these sides, normally the base is a square, so the area is simply side by side, so 10 by 10, and the height is 10 also, so we will obtain 10 cubed, and normally it is 10 centimeter cube. We should keep in mind, and we should very to be careful with the measures, the length is measurement units, and also, but here we are talking about volume, so we put the measurement unit, okay, cubed. With the surface area, or with the area, we put a centimeter square, and with the length we put as a centimeter only. Okay, so when the composite solid is this cube and this cylinder, so we add the resulted volumes. So normally we'll obtain 1628 centimeter cube to the nearest centimeter cube, so to the nearest unit, without taking any decimal places after approximation. So moving on to the next exercise, we have similar exercises, not very strange and not very difficult. So complete to find the volume of this composite solid. Instead of having a cube in the in the bottom of this cylinder, we have a cylinder with a prism, so and rectangular prism, because all the faces are rectangles. And so how about this one? So the area of referring to or talking about the prism, the rectangular prism, the area of the base is a rectangle, so it is a length by breadth, so it is a 12 by 8, and the height is 4, so 12 by 8 by 4, and so it is easy to calculate it, 12 by 8 and by 4. Okay, so easy. So after that, we obtain, for example, x meter cubed, because all the measurement units are meters, so the volume is with meter cubed. And what about the cylinder? Here, the cylinder is, we have as a cylinder, so we know that the diameter is 6 meter, because they give us the diameter and not the radius, but the formula of the volume involved, or the formula of the area of the circle involved the radius. So we know that the radius equal to the half of the diameter. So 6 divided by 2, it is a 3 meter. So 3 meter, and also the height here. We know the height is 10 meter. So normally it is a pi by r squared, which composes our area, the area of the circle of the cylinder. So pi 3 squared by the height, which is equal to 10, and we will obtain a volume. So we add this one to this one, okay, to obtain our volume meter cube to the nearest whole number. And also this involve the same with different dimensions, only the same previous example with different dimensions. You can also investigate, or you can do it by yourself. If we wanted to have or to approximate to the nearest meter cube, we take it without any decimal place, so it is like approximated to 3003 meter cubed here. I will focus in the next example in this one, because as you know, we have an empty pipe inside. So normally the volume of this composite solid is the volume of the big cylinder minus the volume of the empty region inside, because the volume doesn't include any bubbles, any empty area, so empty volume. So normally it is the cylinder minus the pipe inside, minus the small cylinder, the volume of the small cylinder inside. So first of all, we compute the volume of the big cylinder. It is the area of the base by the height. The area of the base, normally it is a pi r squared, and we have a diameter 10 centimeters. So normally the radius is the half, so 5 squared times the height. The height of the both cylinders is 8 centimeters. So we multiply by 8 centimeters to obtain nearest to the 1 decimal places is 628.3 centimeter cubed. Centimeter, because all the lengths are given by centimeter. Volume of the small cylinder, it is the inside one. So we have a diameter 2 centimeters. So the radius is the half, for 1 pi r squared by also the same height, 8, to obtain 25.1 centimeter cubed. And then we subtract both volumes to obtain the filled area, that surround this empty pipe inside. Moving on to the final example, and interesting one. We have this strange composite solid. First of all, we can composite it in our imagination into a rectangular prism, which is in the bottom, and we have like we have a I don't know, like a sector, like a portion of cylinder. We have a sector here, and we have like elongated, or we generate a portion of cylinder from this sector instead of the circle, because we know the cylinder, it is a circle and elongated to obtain, and we can generate from this base a cylinder, and from this sector we if we give it a volume, so we'll obtain a portion of cylinder. So what about this one? So we have a partial, we say a partial cylinder here. So it is the area of the base. The base here is obviously is the sector. So we know the sector is 60 is the alpha, is the angle here, is the angle divided by 360 and multiplied by pi r squared. So pi r squared, we know that this is 4 centimeters, so we identify the radius as 4 centimeters, so 4 squared multiplied by the height, and we identify the height of this partial cylinder by 7 centimeter as similar side of the rectangle prism in the bottom. Normally we will obtain 58.6 centimeter square, because a centimeter cubed, sorry, because we are talking about a volume and all the lengths are given by centimeter. Volume of the rectangular prism in the bottom, the area of the base. The area of the base, it is like a rectangle in the base with the length 7 centimeter, width 4 centimeter, are the opposite. So normally we can multiply 7 by 4 to obtain the area of the base. Or instead of this, we can say that this is the base and we multiply it by the height. It is not a big deal because we will obtain the same 140 centimeter cubed. And finally, we want to add these two measure to obtain a total value volume 198.6 centimeter cube. Here we add because we don't have any empty region. So it is all about adding these two volumes. Thank you for listening, and bye bye.